This is reserve problem number 10 from chapter 6. We will use a single factor ANOVA in this problem. Qualiparts is a supplier of parts to the auto industry. They contract with 4 different subcontractors. They want to test and determine if the strength of wire used to make alternators is significantly higher for any of the potential contractors, of the 4 potential contractors. So the 4 contractors agreed to submit samples from 10 samples using a standardized test that Qualiparts provided, and we are to use a single factor ANOVA using the Excel ToolPak to determine if there is a significant difference between the strength of scores of the 4 contractors. And we are to use a 5% significant level. So in this situation, our ANOVA test is, as I said previously in another video, the null hypothesis always tests for status quo, and it should always have that equality sign attached to it. So we're testing whether mu1 is equal to mu2 to mu3 is equal to mu4, meaning the strength for each of these 4 contractors are equal to each other, and then the alternative hypothesis says mu1 is not equal to mu2, not equal to mu3, and not equal to mu4. So in order to make that this test or perform this test, and we are to use a 0.05 significance level, what we do is we will use the data analysis ToolPak. We'll go to the data analysis menu, scroll down, and oops, no, not scroll down. You use single factor ANOVA right here, and you say OK. The range of data is over here. So I'm going to highlight the whole thing. It is in columns, and the labels have been selected as part of the array. The alpha level, you can set that to be whatever. It is set to be 0.05 by default. And then the output range is, I will put it over here. And we get these results, which, let me make that a little bigger. Okay, so okay. So to interpret, essentially we come to the ANOVA section, and given that our p-value was, or our significance was set to be 0.05. Now, one way that we can answer the question is this right here. Because our p-value is lower than our set significance level, we know that we can reject the null. So if we reject the null, then we can conclude that the strength of these of the wires from all of these 4 providers are not equal to each other. Also, another way that we can do this is by comparing the computed F value versus the critical F value. Because this number is greater than the table or the table F value. This is the calculated from the sample, and this right here is the critical, which is from the table. And because our calculated or sample F value exceeds or is greater than the table or the critical F value, then of course we know that we can reject the null and accept the alternative. Actually, it's not quite true that you can say you accept the alternative. The correct way of saying it is we cannot, but we reject the null, therefore we cannot reject the alternative. So we say we cannot reject the alternative. And therefore, our conclusion is at the 0.05 significance level, actually at a 0.0005 level, that the wire strengths from these four suppliers are not equal to each other. And then if you wanted to expand on it, you can see that the averages are listed here. So more than likely, supplier A has a higher strength than supplier B. Okay, I hope you found this helpful.